This is fifth experiment of big data, creating data frames in Spark SQL, creating the dummy file CSV file with the open file name called people.csv. While it opens a file called people.csv for writing, the block ensures the file is closed automatically when it is done. Then f.write will write the header line containing two columns, names like name and age like in is a new line. Each subsequent it will write a CSV row for one person. After this block you have a text file called people.csv with 4 lines, and then it will import the Spark and setup. From PySpark.sql import Spark session, imports the Spark session, the entry point to use Spark SQL, and DataFrame APIs in PySpark. From PySpark.sql.types, imports classes used to declare an explicit schema for a data frame. And then from PySpark.sql, it will import row. To convenience, a class used to create row objects when converting RDDs into data frames. Then Spark session.builder, which will create a builder for a Spark session, and then by the .app name, it will set the name shown for Spark application, and it is useful in UI and logs. .get or create of, either it will returns an existing Spark session or creates a new one. And after this, it will handle the Spark functionality like data frame API SQL underlying Spark context as per Spark context, etc. Then it will create a data frame from a Python list of tuples. Data is a plain Python list of tuples because each tuple represents one row as name and age. Spark.create a data frame converts the Python list into Spark data frame with column names, name and age. Then Spark infers the column type automatically, and it will pass the native Python types. df1.showOff, it will print the data frame content to the console in the table form. df.print schema, it will print the data frame schema, and it will confirm types inferred by the Spark. Then it will create a data frame from an RDD with an explicit schema. Spark.context.parallelize, it will create an RDD from the Python list because an RDD is a Spark low level distributed collection type. Then schema is a structured type, builds an explicit schema object. Then struct field, a field called with the name type. Then a string type is true, which means the field is nullable. Then struct field age integer type is also true when the age of type is integer. Then rdd.map, it will transform each tuple into a row object for name fields. Then it will create a data frame from the RDD and applies the explicit schema you defined because you provided Spark use those types rather than inferring. Then dataframe2.show and dataframe2.print schema of, it will display the data and the schema. It is used when the reading or creating data that comes an untyped RDDs, and it will control over column names and types. Also, it is helpful to avoid wrong time inference for the performance in some ETL paths. And then it will read the data frame from the CSV file. Spark.read.csv, it will read the CSV file into data frames. Here header is true, which it will tell Spark the first line is a header with column names. Then infra schema is equal to true, which will ask the Spark to try to infer column data types automatically by scanning the data. Then dfcsv will have the same rows as the file. Show off, it will print the print schema, shows detected types like name, string and age as integer. Then we will run an from SQL using a temporary view. df1.create or replace temp view, it will register df1 as a temporary SQL with name with the view named people in the current session. This enables running SQL queries over the data frame using Spark.sql. Then spark.sql, it will select the age and runs SQL's query that groups row by age and counts how many rows have that age. Then it will shows the query result. Then we have got the output as data frame from the list of tuple as John, Alice and Bob, and this is the output of the fifth experiment. Thank you.